Let's take a look at 9.1, which is inverse functions. Okay, so we want to show that f of x equals x to the third minus 2 is 1 to 1. Graph with a graphing calculator or Desmos if necessary, and write a sentence or two explaining why. Okay, if we graph it, we can tell that it is 1 to 1 because it passes the horizontal line test. Okay, so we can say that f of x passes the horizontal line test. We can also show that if f of a equals f of b, which means a to the third minus 2 equals b to the third minus 2, which is a to the third equals b to the third, and if we take the cube root of this, then a equals b. So that's that definition. Well, why does this work? That is because if x is greater than 0, then x to the third is greater than 0. And if x is less than 0, then x to the third is less than 0. So you can do it several different ways. The horizontal line test, and which is kind of all explained by this. When you're taking something to the third power, if x is greater than 0, then x to the third is greater than 0. There's no overlap like there is when it's a square root. Okay, show that f of x equals x to the third minus 2 and g of x equals x, the cube root of x plus 2 are inverses. Okay, well, if they are inverses, then f of g of x is equal to g of f of x, and they are both equal to x. Okay, so if I make x to the f of x this, and I make g of x blue, if I want to find f of g of x, then that means wherever I see an x in f, I'm going to replace it with the cube root of x plus 2 to the third minus 2. Well, the cube root of x plus 2 to the third is just x plus 2 minus 2, which gives me x. Then g of f of x is I'm going to take the cube root, instead of x, I'm going to put in x to the third minus 2 plus 2, which gives us the cube root of x to the third, which is x. So that satisfies the definition. Okay, find the inverse of this one-to-one function. So f of x is the cube root of 3x minus 1. Find the domain and range of f inverse. Well, since this is a cube root, there are no limitations on the domain. So for f of x, the domain is all real numbers. It's only if it's an even root that you have to limit the domain. Oops, sorry, I scooted that over too far. And the range is also everything. There's no limitation on the domain or the range. Okay, so now to find f inverse of x, I switch x and y, then solve for y. Okay, so I start out with y is equal to the cube root of 3x minus 1. I switch the x and the y, so this gives me x is equal to the cube root of 3y minus 1. And now I solve for y. So of course the first thing I'm going to do is I'm going to take both sides to the third power. So that gives me x to the third is equal to 3y minus 1. Add 1 to both sides, and I'll go ahead and finish that up here. That gives me x to the third plus 1 is equal to 3y. And then I'll divide everything by 3, and I get x to the third plus 1 over 3 is equal, whoops, I forgot to put dividing 3 over here, is y. So that tells me that f inverse of x is x to the third plus 1. And I keep doing that, I'm so sorry, divided by 3. Oh, and I forgot to put the domain and range. So for f inverse of x, the domain is everything. A cubic function has an unlimited domain, and the range is also negative infinity to infinity. There's no limitation on the range. But you can also think about it, since it's 1 to 1 and you found the inverse, the domain of f of x is the range of f inverse. The range of f of x is the domain of f inverse. Okay, so let's see. We've got a 1 to 1 function, f of x equals the square root of x minus 3. Okay, well, for f of x, this has to be x minus 3 has to be greater than or equal to 0, which means that x has to be greater than or equal to 3. So my domain is 3 to infinity. Okay. Now my range on this, I know that since this has to be greater than or equal to 0, then the square root of x minus 3 is greater than or equal to 0, so my range becomes 0 to infinity. All right, so let's find the inverse. So I start out with y equals the square root of x minus 3. So now I'm going to switch the x and the y. So x is the square root of y minus 3. Now I'm going to square both sides, which tells me that x squared is equal to y minus 3. When I add 3 to both sides, I get that x squared plus 3 is equal to y, which in turn gives me f inverse of x is equal to x squared plus 3. So f inverse of x, the domain is going to be the range from here. So it is going to be 0 to infinity, and the range is going to be the domain from above. Now, if you look at this graphically, if you start out, and I'll just do a real quick sketch here. If I graph f of x, it's going to be the graph that looks like this. So you can see that your domain goes from 3 to infinity, and your range goes from 0 to infinity. If I graph its inverse, it looks like this. So again, you can see, and this of course is because you're reflecting it across, whoops, I just threw a pen across the room, the line y equals x. And you can tell that the domain, it's only where x is greater than or equal to 0, and for your range, it's only where 3x is, or y is greater than or equal to 3. Okay, find the inverse of the function x over x plus 2. Find the domain and range. All right, so for f of x, we have a vertical asymptote of x equals -2 if I set that denominator equal to 0. So that tells me my domain is going to be -infinity to -2, and then from -2 to infinity. I have a horizontal asymptote if I look at my degrees of y equals 1. And this one doesn't cross. So for your range, you're going to have -infinity to 1, and then 1 to infinity. Okay, so hopefully everything else will work out. All right, so if I start out, I have y is equal to x divided by x plus 2. I'm going to switch the x and the y, so x is equal to y divided by y plus 2. Okay, so I can just put this over 1. I can cross multiply. This gives me y is equal to x times y plus 2. So y is equal to xy plus 2x. Now I want to know what y is equal to. So I'm going to put my y's over here. So this gives me y minus xy is equal to 2x. If I factor out a y, I get 1 minus x is equal to 2x. And I'm going to have to go up here now. If I divide both sides by 1 minus x, I get that y is equal to 2x divided by 1 minus x. So that tells me that f inverse is equal to 2x divided by 1 minus x. Now my domain and range for f inverse, well, now I have a vertical asymptote of x equals 1. So my domain is going to be from -infinity to 1 and 1 to infinity. And for my horizontal asymptote, I look at my coefficients here. So this is y equals -2. So my range is -infinity to -2 and -2 to infinity. Now, once again, you can also tell that by the domain of f is the range of f inverse. The range of f is the domain of f inverse. I need to scoot this over because I seem to keep getting off frame. All right, the function f of x equals x squared minus 5 is not one-to-one. Restrict its domain so that it is one-to-one. Then find its inverse. Okay, well, if we look at the graph of x squared minus 5, and we're just going to do this very, very briefly. 1, 2, 3, 4, 5. This is the quadratic function that has been moved down 5 units. To get it to pass the horizontal line test, I need to get rid of half of the graph. So I'm going to restrict its domain to being just this part. Okay, so I'm going to restrict the domain 0 to infinity. That makes the range -5 to infinity. Okay, so now I have restricted the domain, find its inverse, and find the domain and range of that. Okay, well I can hopefully do that. All right, so if I have y equals x squared minus 5, and I switch the x and the y, add 5 to both sides, take the square root of both sides, and I get y is equal to the square root of x plus 5. So that tells me that f inverse is equal to the square root of x plus 5. Now, again, if I want to graph that real quickly, the square root function looks like this. So 1, 2, 3, 4, 5. Okay. So it starts x plus 5 has to be greater than or equal to 0, so x is greater than or equal to -5. And then it goes like this. Okay, and again, that's a really rough sketch. Okay, so for the inverse, for f inverse of x, the domain is -5 to infinity, and the range is 0 to infinity. And again, it matches up. Okay, are they one-to-one? Write a sentence or two explaining why or why not. Okay, so for my first one here, it fails the vertical line test. So this is no. It fails the vertical line test. Okay. Now we can do that a little bit more thoughtfully here. We can say, okay, well, if this is -8, we know that f of -8 is equal to 4. And we know that f of 10 is equal to 4. So f of -8 is equal to f of 10 but -8 is not equal to 10. So that follows the definition. For B, it in fact is, because if you look at this, yes, it passes the vertical line test. Okay, and that's a good place to quit for this.